Hello everyone, and welcome back to our CloudNetX course. Today we'll explore key concepts like Layer 2 and Layer 3 devices, the three-tier hierarchy model, the roles of intermediate distribution frames, and main distribution frames, and more. Let's start by discussing the foundational components of any wired network, switches and routers, and their roles in Layer 2 and Layer 3 functionality. At Layer 2 of the OSI model, switches are responsible for forwarding data within a local network segment using MAC addresses. These devices are excellent for enabling fast, efficient communication between devices on the same network. However, they lack the ability to connect separate networks. That's where Layer 3 routers come in. Routers operate using IP addresses and are essential for interconnecting multiple networks. They enable data to travel between different subnets, offices, or even to external networks like the Internet. Layer 3 switches can combine the speed of Layer 2 switching with routing capabilities, making them a versatile choice for modern networks. Now, let's move to the three-tier hierarchy model, which is widely used in campus network designs to organize and optimize traffic flow. This model divides the network into three layers: core, distribution, and access. The core layer is the backbone of the network, designed for high-speed data transfer between distribution layers. It's optimized for reliability and performance, with minimal latency. The distribution layer acts as a bridge, connecting access layers to the core. This is where policies, routing, and access control are implemented. The access layer is where devices like computers, printers, and IP phones connect to the network. It's designed to handle local traffic and provide connectivity for end users. A campus network's physical infrastructure depends on intermediate distribution frames and main distribution frames to manage and distribute network connectivity. The MDF is the central hub where external connections, such as ISP links, enter the network. It houses the primary networking equipment, such as core switches and routers. IDFs are distributed throughout the campus to extend connectivity to different floors or buildings. These frames connect to the MDF via high-speed uplinks and house access switches for localized devices. When multiple switches are interconnected, there's a risk of network loops, which can cause broadcast storms and degrade performance. Spanning tree protocol solves this problem by creating a loop-free logical topology. STP achieves this by identifying and disabling redundant paths while maintaining alternative routes for redundancy. Next, let's discuss Session Initiation Protocol, a signaling protocol used to initiate, manage, and terminate real-time communication sessions. SIP is widely used in applications like voice over IP and video conferencing. Finally, we have the real-time streaming protocol, which facilitates the delivery of streaming audio and video content. Unlike SIP, which manages communication sessions, RTSP is focused on controlling the playback of media streams, such as pausing, fast-forwarding, or resuming content. In summary, designing a wired campus network requires careful consideration of both the logical and physical components. Thank you for joining us today, and see you soon.